You're welcome to another session of the lectures for today. Last week, we rounded up on the types of descriptive statistics. So tonight, we want to really define all the types of descriptive statistics under statistical computing. So we want to define what mean is. We want to look at mean, we want to look at mode, we want to look at median, we want to look at range. We also want to look at variance and standard deviation. And after we would have gotten the definition for all this stuff, we will go into a short period in calculations, on simple calculations concerning these definitions. What does mean means? What does mean stands for? Mean is just a simple average of values in a set of data. So we can easily say it is mathematical average of all terms. That is, when you are given a set of data, all the variables in that set, you will need to add them together and then divide by the number of values or items, whatever name you can call it, to get your mean, which is the average. So when we talk about mode, I told us the last time that mode, if we have two types of mode, like in a set of data, there is something we call bimodal modes or trimodal. Mode generally means most frequently occurring values in a set of data. And where you now find out that those values that are frequently occurring are more than one, it means you are either having bimodal or trimodal type of mode. But the most popular one is just the ordinary mode, which is common to everybody. So mode is the most frequently occurring value in a set of data. I want us to note that very well. Then when we talk about median, as the name implies, the mid value of observations, the mid value of all values in a set of data. That is, that number that falls in the middle of the set of data is your median. So where you are having like 2, 3, 4, 5, 2, 3, 4, 5, 6, your median supposed to be 4, because 4 falls in the middle. So where the values are scattered, you will need to rearrange in order to get your points from the arrangements. So median is the mid value of observations in a set of data. Then range. Range is just the difference between the maximum and the minimum value in a set of data. Between the highest, the difference between the highest and the lowest value in a set of data, which means like the one I use as example now, 2, 3, 4, 5, 6. That means 6 is the highest value and 2 is the lowest value. That means 6 minus 2, you get your 4. So 4 is your range. Now, we are coming to variance. Variance. Variance is defined as the average of the squared differences on the mean. Variance is defined as the average of the squared differences on the mean. Okay? Is the average of the squared differences from the mean. That means if you want to get your variance, you are going to square your standard variation. That means standard deviation squared. Your standard deviation, you are going to square it, at least times 2. And in order to get your standard deviation, you are going to square root whatever you have in variance. So I will give you the steps to calculate variance. Number 1 step is that you work out your mean. After working out your mean, you are getting the average. After you might have rearranged the values, then you work out your mean to get your average. Then for each number in the values, you will now subtract that mean from each of the numbers, and then you square it. I hope you are following, because we are going to do a brief, simple calculation right now. You will work out your mean, then for each number in the set of data, you will now subtract that mean, which is your average, from each of the numbers, and then you go into squaring. You square it. That is, if it is 1, you make it 1 squared. After squaring it, then you will now work out the average of those squared differences. By the time we start the working now, you will get it. So whatever you now get from variance, it is the square root you will now use to get your standard deviation. Okay? So I want to give us a set of data quickly. A set of data quickly. And I start. 2, 6, 4, 5, 4. 2, 6, 4, 5, 4. And you are going to calculate your mean, you are going to calculate your median, you are going to calculate your mode, you are going to calculate the range, and you are going to calculate variance and standard deviation from this. So how do we go about it? Let's start with mean. So if I were you now, I would just advise you to rearrange those values in that set of data. It is written 2, 6, 4, 5, 4. So I would advise you to now rearrange, and in your rearrangement, it will now become 2, 4, 4, 5, 6. 2, 4, 4, 5, 6. Now to work out your mean, it's just a matter of calculating the whole values and divide by the number of values in that set of data. So when you calculate this now, you will get 21. That is 21 over 4. Approximately, 21 over 5. Approximately, your mean is 4. I believe you are following. Then, if you want to work out your median now, after rearrangement, of course, we have 2, 4, 4, 5, 6. So which means 4 is your median. 4 is in the middle. That is a median. Now to get your mode from here, which one is the most occurring, frequently occurring values here? If you look at it very well, you will notice that we have 2 of 4. And that's the only one where we have 2. The others are just 1, 1. And we have 2 of 4 here, which means your mode is 4. Your mode is 4. Range, like I told you, is the difference between the highest and the lowest value in the set of data. So, which means you are going to subtract 2 from 6. You also get 4. Okay? You also get 4 from this. Now, let's go straight to variance. This is where we are going to be very, very careful in the workings. Already we have our mean, which is the average, as 4. Because the first thing you will do is work out your mean, that is the simple average, which we have already done from the workings of mean. That means we are having 4. Now, in statistics, in calculation in statistics, you don't write minus. Okay? So which means that 4, you are going to minus it from 2, you get your 2. Okay? 4 from from the first 4, you get your 0. 4 from the second 4, you get your 0. 4 from 5, you get your 1. 4 from 6, you get your 2. Now you are going to square all these numbers, all these values, which means 2 will be squared, 0 will be squared, second 0 will be squared, the 1 after it will be squared, and the last 2 will be squared, which means you are having 4, 0, 0, 1, 4. 4, 0, 0, 1, 4. Now that you have squared it, you are now going to add the whole 5 together now. 2 times 2 is 4, 0 times 2 is 0, 0 times 2 is 0, 1 times 1 is 1, 2 times 2 is 4. So you are going to add the whole 5 now over the number of values now to get your variance. That means 4 plus 0 is 4, plus 0 is 4, plus 1 is 5, plus 4 is 9. That means 9 over 5. And when you divide 9 by 5, we have an approximation of 2. So you are going to square your 2 now. You're going to make it 2 square. That is your variance. 2 square now is equals to 4. 2 times 2 makes 4. That means your variance is 4. And if you want to get your standard deviation from this 4, you are going to do the square root. And the square root of 4 will be 2. I hope we are done with that. Now, I can even ask a question this way. as concerning variance and standard deviation. I can say if your variance is 9, what will be your standard deviation? Or I can say if your standard deviation is 9, what will be your variance? So in such questions, you already know that variance is standard deviation squared, and your standard deviation is square root of variance. All you will do, where you are given 9 for standard deviation and you want to work out variance, you just go into square roots straight away. Square root of, standard deviation squared. That means 9 times 9, that will be 81. And if it is variance that you are given 9 to work out standard deviation, which means we are going to square root 9, that means we are getting 3. So I think we are done with descriptive statistics to some extent. I want us to go to statistical inference. That is the second type of statistics. The second type of statistics. I told us that inferential statistics refers to the statistical procedure which allows the researcher to make inference on the entire population based on a sample of the population. So, first and foremost, we're going to quickly tackle hypothesis testing before we go into the types of inferential statistics. Or maybe we'll just leave this one for now. Let's go straight to statistical comparison, which is the types of inferential statistics. Then we'll come back to the hypothesis. Inferential statistics are divided into two. Inferential statistics are divided into two. We have the parametric statistics and we have the non-parametric statistics. Parametric statistics and the non-parametric statistics. Okay. Under these parametric statistics is a statistical method in which the data is required to fit a normal distribution. The data is required to fit a normal distribution, while that of non-parametric statistics is not required to fit a normal distribution. Okay? So we have some examples of parametric statistics. We have what we call t-test. We have Wilcoxon test, Wilcoxon test, W-I-L-C-O-X-O-N, Wilcoxon test. We have Mann-Whitney test, M-A-N-N-W-H-I-T-N-E-Y, Mann-Whitney test. We have the ANOVA test. We have the Kruskal-Wallis test. We have the Friedman test. We have the correlation test. So we're going to look at this under parametric statistics. All these are examples of parametric statistics. Now, what do we mean by the t-test? T-test is a statistical test that is used in comparison of parametric data. It is a statistical test that is used in comparison of parametric data. Wilcoxon tests are statistical tests that is used for comparison of non-parametric data. It's a statistical test that is used for for comparison of non-parametric data. Mann-Whitney is a statistical test that is used as comparison of two unpaired samples and non-parametric data. Mann-Whitney is a statistical test that is used as comparison of two unpaired samples and non-parametric data. ANOVA test. The full meaning of ANOVA is analysis of variance. Analysis of variance. So ANOVA test is a statistical method that compares parametric data. Is a statistical method that compares parametric data. All these ones are only ones you to understand the definition. Don't bother yourself too much. Just understand the definition, and that's all. Kruskal-Wallis is used for non-parametric data. Kruskal-Wallis is used for non-parametric data, while Friedman test is similar to Kruskal-Wallis and is a non-parametric test. It's a non-parametric test. Now, the last one here under the parametric statistics is correlation test. This is the last one we'll treat under the parametric test. Statistics. Correlation test finds a correlation between two data groups. It finds a correlation between two data groups. I only want you to understand the definition. Don't bother yourself. Just understand the definitions. The areas where I want you to work out calculation, I will let you know. Correlation test finds a correlation between two data groups. Non-parametric. Non-parametric statistics refer to a statistical method in which the data is not required to fit a normal distribution. Non-parametric statistics refer to a statistical method in which the data is not required to fit a normal distribution. I only want you to understand the definition, okay? So in statistics, parametric statistics includes parameters such as the mean, median, standard deviation, variance, etc. like that. You see, while non-parametric statistics makes no assumption about the sample size or whether observed data is quantitative or not. So it does not assume that data is drawn from a normal distribution. I think we will stop here for tonight and give room for question because we are like having 8 minutes to go. It's time for question now. It's time for question. Question time. Let us ask question at this point now. Aywa bami o. On fait comment tu es en mute, arabe. On fait comment tu es en mute. Abi. Hello. Question time. Anybody want class here? Question time. Hello.
Student,
Hello.
if you have any question, you can unmute yourself. Student, please, you can unmute yourself and ask your questions. If you have any question, unmute yourself.
I doubt if any students online.
If they don't have any questions, they are online.
Okay. I think I will give an assignment now against next week. A set of data has the following: 3, 8, 3, 8, 4, 8, and 2. 3, 8, 4, 8, and 2. Calculate the following: 1, mean, median, mode, range, variance, and standard deviation. That is the assignment for tonight. Thank you. I still have about 4 minutes if there is still any question to be asked.
Sir, raised up. Excuse me, sir.
Okay? I'm listening to
Sir,
you.
you didn't tell us your email address.
My email address.
Sir, your email address. Yes, sir.
Can you listen to me now?
I can.
S double
Yes, sir.
A
Yes, sir.
K O
Okay.
R O.
Yes, sir.
Then you put
Okay, sir.
1. Listen to me
Okay.
now. Listen first. SAAKORO. Then you put 1 at gmail.com. Can you repeat it now?
Yes.
Yes.
SAAKORO1 at
Yes.
yahoo.com.
At
Sir, the S, is it small?
gmail.com. The
Okay,
number
gmail.com.
S
Sir,
as in Sherry.
is
As
it capital or small letter?
email is small
The
letter
S.
now.
Okay.
Everything is small letter in email. At
Okay.
gmail.com.
All right, sir. Thank you,
Okay.
sir.
All right. We are still having 2 minutes to go. If there are questions.